everyone, my name is Nasron Ophelia and my NPM is 233-12014. And in this presentation, I will be explaining the selection of the most suitable software development lifecycle or SDLC method for an embedded system project in autonomous vehicle. While I'm the one delivering this presentation, the content and analysis presented here are the result of a thorough discussion and collaboration with my group members. We explore the unique challenges and needs of this project together, especially considering the critical role of embedded system in ensuring the safety and then performance and reliability of autonomous vehicles. Choosing the right SDLC method is vital in this context and throughout this presentation. Of course, and I will walk you through the reasons behind our choice. So, let's get it. And then this slide, we can see case scenario overview. The case scenario involves a leading automotive manufacturer that is embarking on a major project to build an advanced embedded system for its next generation self-driving car. The system includes several major components such as sensor integration and then real-time data processing and continuous communication with the vehicle's control systems. The development team consists of experienced professionals with deep knowledge in embedded systems, real-time operating system, and automotive safety standards. This kind of project demands a very structured, disciplined, and well-documented approach to ensure both success and safety. Alright, now let's move on to the project requirements and constraints. The embedded system must perform in real time with extremely high reliability and compliance with strict automotive standards. On the other hand, the project faces several constraints. There's an aggressive timeline to meet the market demands, and then dependencies on specific hardware, a limited budget, and the risk of integration issues arising late in the development process. So, the SDLC method we select must be capable of handling all of these challenges. After careful analyzing and group discussion, here we choose the V model as the most suitable SDLC method for this project. The V model is an extension of the waterfall model, where every development phase is mirrored by a corresponding testing phase. This is especially important in safety-critical systems, where mistakes must be caught early. The structure and discipline of the V model allow for thorough verification and validation at every step, which aligns perfectly with the needs of an autonomous vehicle system. And then next is SDLC selection factors. Let's now discuss the 6 selection factors from this scenario. First is user requirements clarity. The user requirements are already clearly defined, which suits the V model well because it requires prices documentation from the start. Prices documentation from the start. And then second is familiarity with technology. The team has strong experience with embedded systems, making them comfortable working within a structured environment like the V model. And then third is system complexity. Since the system involves complex real-time instructions between hardware and software, a rigid and test-driven approach is essential. And then 4 is system reliability. This is perhaps the most critical factor. Any software failure in a vehicle can lead to severe consequence, the fee models focus on early and repeated testing ensures reliability. And then fifth is time schedules. Even though the schedule is tight, the fee model's clarity helps avoid major issues late in development, which saves time overall. And then sixth is schedule feasibility. Managers and stakeholders require full transparency into progress. The fee model provides well-defined milestones and documentation that make it easier to track progress and spot delays early. Alright, and then next slide is team capabilities and resources. The capabilities of the project team also support the decision to use the fee model. They are proficient with real-time operating systems and automotive standards, and they are used to working with structured methods that makes them highly suitable for the discipline and systematic process that the fee model demands. Their skills will help ensure that each development phase is completed correctly before moving on to the next. And then here, next is project risk and uncertainties. This kind of project also comes with various risks. For example, is integration between hardware and software could fail if not tested properly. Real-time processing might run into performance issues or data bottlenecks. There's always a possibility of delays in getting regulatory approvals or supply chain problems affecting hardware availability. The fee model allows us to plan for these uncertainties with clear task plans and fallback measures. By identifying errors early, the team can reduce the chance of project failure. And then next is speed to market importance. Speed to market is another major consideration. The automotive industry is highly competitive, and launching the autonomous vehicle as soon as possible is crucial. While Agile may seem like a faster method, the fee model actually helps us deliver quickly and reliably by reducing rework through early and frequent validation. This means fewer bugs, fewer delays, and better product at launch. And that next slide is why didn't we choose other SDLC models? Alright, first is waterfall. Waterfall is similar to fee model, but lacks parallel testing activities, making it riskier for critical systems. And then second is Agile. Agile is too flexible and doesn't prioritize documentation or safety, both of which are non-negotiable in automotive projects. And then Spiral allows for risk management, but it's too complex and costly for this specific case. And then iterative development might work in simpler software systems, but is not ideal when hardware, software integration, and real-time performance are crucial. So only the fee model combines safety and then structure, reliability, and documentation, making it the best match for our scenario. And then next, last is conclusion. Alright guys, in conclusion, based on thorough group discussion and a complete analysis of the case scenario, we firmly believe that the fee model is the most appropriate SDLC method for this embedded system project. It is designed to handle complex, high-risk environments like those found in autonomous vehicles. It ensures reliability, encourages early testing, and supports traceability across every phase of the development. It also allows the team to maintain quality without sacrificing the aggressive timeline needed to um, compete in the market. Other models either lack the structure, the level of documentation, or the safety verification needed for this kind of project. Therefore, our team confidently recommends the fee model as the best solution for these embedded development challenges. And this decision was result of in the deep discussion within our team. We analyzed each method careful and match it against the scenario requirements. As a team, we considered all possible outcomes and agreed that the fee model would give the project the heights the chance of success. Maybe this is the discussion from me. Please apologize if there is something wrong in the discussion. Thank you and see you.